Okay. So, welcome to everybody who's joining us virtually. My name is David Potenziani. I am hosting the series of health informatics seminars this year. We have a very interesting speaker and a very interesting topic today, something that relates to an episode in my career. Our speaker is from UNC Charlotte. Dr. Rajib Paul has research expertise that includes Bayesian methods, spatiotemporal statistics, infectious disease, injury, and violence prevention, as well as the social determinants of health. So that's a very big waterfront. But today he is going to help us understand his approach for the classification and nowcasting of homicide using natural language processing and spatial analytics. Dr. Paul, over to you.
Thank you, Dave. I appreciate the opportunity to present our work to you all this afternoon. And thanks for organizing these health informatics seminars. And it's a pleasure to present the work that we have done over the past year on classification and nowcasting of homicide using natural language processing and spatial analytics techniques. We have a quite large research team, like Dr. Lina Zhou, Dr. Dongsong Zhang, Dr. Ahmed Arif, who are professors at UNC Charlotte. Then we have Janice Williams, who is the director of Carolina Center for Injury Prevention, Atrium Health. Dan Han is one of our former doctoral students, who is now a tenure track assistant professor at University of Louisville. And then we have 4 students, doctoral students, as well as the master students who worked very hard on this project. This project was funded by an award from the American Public Health Association through Centers for Disease Control and Prevention. And the work that we are presenting today, or our viewpoints, are completely ours, and it's not an official viewpoint of American Public Health Associations or the Centers for Disease Control and Prevention. And here we'd also like to acknowledge the wealth of knowledge that was shared with us by Daniel Buen, Janet Blair, and Akadia Kachauchana from the Centers for Disease Control and Prevention, and also Mr. Scott Prescott-Oldbell, who is like the part of North Carolina Department of Health and Human Services. And Scott is responsible and lead the effort for North Carolina violent death reporting system to the national system, Scott and his team. In today's presentations, I'm going to present 2 parts of the work that we have done. One is the nowcasting of county-level homicide using the spatiotemporal analytics. Here we included the NVDRS data as well as the newspaper articles and also like quality of life measures. And in the second part of the talk, I'm going to talk about the automatic classification of the circumstances of homicide, which is actually in more technical term called the manner classification or the manner of death using natural language processing and the large language models. So what's the context of the research or the background? A study, an article which analyzed the data from 1981 to 2023 found that for the age group 1 to 44 years, the homicide was the 3rd leading cause of death. Of course, there is a overall decline in the homicide rate from 2022 after a sharp increase of 35% between 2019 to 2021, but there are geographic disparities because all places do not see that or experience that decline at the same time. And other disparities include substance use, alcohol use, and also mental health and other socio-demographic disparities. North Carolina has experienced like an elevated, higher, I'd say, like the national rate. The 2023 North Carolina age-adjusted homicide rate is 8.5 per 100,000, where the national rate is 6.8. Then one of a rich source of data to do research on homicides is actually the National Violent Death Reporting System data, which provides a comprehensive and detailed surveillance of the violent deaths. However, like there are a lot of text data there from the medical coroners and then legal experts report that need to be processed before actually we can get the National Violent Death Reporting System data for a particular year to analyze. And that takes like a kind of 2 years because it's not an automated process. So those things are done manually. So manual abstraction of the text data. So that was one of our motivation, like if we could provide them with a tool and showed like there are some reasonable amount of success where processing the text data, the classification of homicide, or at which circumstance the homicide occurred, then it probably speed up their effort in getting the data ready for surveillance sooner. And when there is a data lags, then obviously it requires also, like if you want to do some predictive model, then it requires some kind of an efforts and some analytic approaches so that you meaningfully predict so that all the public health intervention efforts can be targeted or designed accordingly. In North Carolina, as you can see, they have a dashboard, the NCVDRS data set, North Carolina Violent Death Reporting System database. And according to that dashboard, if you go there, you will see like 80% of the homicides are firearm related. And then the others 20% include like sharp instrument, blunt instrument, or personal weapons or other type of mechanism. So what is nowcasting? Nowcasting is an interesting term. It actually talks about estimating the past, looking at the present, and then also like predict the future. So it's all together, three things together. What's the importance? It enables early warning and improved surveillance, okay? Because we all want to know how the future look like. So like when we do it also for the like the share markets, and then we can weather also we do. So here is our effort to do it on the homicide trends. And so far our knowledge is concerned, we didn't see much work done at the temporal level. It has been done, but not at the time and space, both at the spatiotemporal level. And for the homicides, there are like multifactorial drivers because it's a very complex, like nonlinear interactions of socioeconomic, demographic, and situational factors that contribute to homicides. And then data quality and timeliness is also kind of a challenge because NVDRS data have a 2-year time lag, which is definitely one of the reliable and authentic source of data. But often we also get the information on the homicides from the newspapers. Now, newspaper articles like provide kind of an initial information. So you can see like it's kind of a real time in that sense. But it's also inconsistent and biased because not all homicides are actually reported in the newspaper. And we had the opportunity to discuss with one of the leading newspapers editor in North Carolina who covers homicide reports to provided us some insights how they cover them. And then another issue is the spatiotemporal volatility. Because homicides is also kind of, if you think in terms of the data, it's also an impact on the localized and abrupt changes that occur in the community. For example, if you look at like there are, of course, like a lot of efforts going on in the community to lower the homicide or from the injury and violence prevention perspective. So one example is in Charlotte region, they have a way forward, which which aims for lowering the homicide by 10% in 2028. But those efforts, you probably won't be able to get a consistent data set on that. So obviously, that's one part of the limitation also of our research, that the local efforts are not included, as we don't know like where to look for them, and what's the way of collecting the efforts, that the community-based efforts that are or sometimes these efforts could be also like short-term. So we don't know about those information. So that's not part of our data or in the prediction model. And then uncertainty in the predictions, both are contextual and data-related uncertainties, because we did see like different sources like offer different numbers. So there is probably kind of an like little bit of measurement discrepancies of how these homicides are actually reported. So for this part, our goal is to enhance the homicide surveillance by developing a spatiotemporal model, and then validate that model using the Bayesian posterior predictive checks, and then also contextualize in terms of the homicide risk within the socio-demographic and the structural determinants. The four data sources that we used are National Violent Death Reporting System data, then county health rankings and roadmaps data, CDC's Social Vulnerability Index, and then newspaper articles, which are available open source. For this part of the study, we restrict the years from 2016 to 2023. Though North Carolina is one of the early contributors for the NVDRS database, which has data since 2004. But we saw like going beyond 2016 for the newspaper articles, because the digitization of the newspapers coverage was not that great, like if we go beyond 2016. So we decided to restrict our study from 2016 to 2023. And here the goal is to predict homicide rate at the annual scale, so annual homicide rates. But many offices do report the data at like in 6 months. So our models can easily be scalable to like 6 months if anyone wants to apply it. NVDRS, since 2018, it covers all 50 states, including DC and Puerto Rico. And then it provides rich contextual data on mental health and firearm type, what the relationship dynamics are, because sometimes homicide could be a result of interpersonal violence. So those informations are there. It includes 600 variables. And the source of NVDRS data are death certificates, law enforcement report, and medical coroner's report. And then recently, actually, when we were working on this project last year, then as we are discussing with the NVDRS team from the Centers for Disease Control and Prevention, they were asking us to look at the SVI and then the county health rankings and roadmap, which we did. And because they were thinking of including those data set or linking that data to the NVDRS. And currently, if you go to their website, you will see that it has been linked. And we also saw in our analysis, so there is some associations between those variables and the homicide rates. And then county health rankings and roadmaps that give like demographics data, socioeconomic data, and other health measures data, which covers 3,143 United States counties. And it's compiled data from census, CDC, and BRFSs. Those are kind of their data source based on what they estimate the rates. They also provide the precisions for the rates, and those data sets are available, like they update every year. So you can get new estimates every year. Now, the social vulnerability index, as the word says, like it measures the vulnerability of a county, and it gives like an overall vulnerability score. Like it's usually percentile rank, what's the report, from 0 to 1. The higher the number, that means that county is more socially vulnerable. And how it's calculated is it's combined like 16 variables, as you can see on the screen, from below 150% poverty, unemployment rate. And it also considers like 4 themes. So socioeconomic status, household characteristic, racial and ethnic minority status, and housing type and transportation. So SVI are computed like an overall measure as well as a theme specific measure. So the theme specific means the 4 themes that you are seeing on the screen. And for each theme, there is also an SVI measures available. And for the newspaper articles data, we consider more than 30 publications, like in not from North Carolina, as we listed some on the screen. And how we extract the newspaper articles data is first we converted it into the text format, and then clean the text. And then we use Python to extract the information on the homicide. Like we select a list of keywords, and those keywords were used to extract whether the news is on homicide or the murders or gun or violence. And then we recorded the incident date and the location and the county, and of course the source of the article. Then also we manually verify some of the information just to make sure that the procedure that we are using is effectively working. Now, when we get the counts of newspaper articles reported by the number of homicides at the county level, like more than one newspaper can actually report the same incident. So it's not just, you cannot just simply take the count, so you have to do a deduplication. So the deduplication is done several ways. So if there are 80% of the text similarity or the headline similarity, or like the spatiotemporal proximity, whether like the two like incidents are reporting at the same place, almost very close to the same time. So this is how we deduplicate, and then we create a data set of the homicides that are reported through these newspaper articles. Okay. Now our goal was not to use the newspaper articles actually as an outcome, but using it as a predictor, because with the notion that if the homicide rate increase, then the reporting in the newspaper articles will also increase. So there is a positive correlation. And later I'll show how those correlations look like. So the newspaper article data are actually used as a predictor variable. So here is our modeling framework. In our spatiotemporal negative binomial framework, we put the NVDRS data, the homicide reported for the North Carolina at the county level. And then also we include the social determinant of health plus the demographics variable there. And then we use a binomial autoregressive model, which is called a bar model, where the newspaper articles data were modeled using that distribution. And I will explain in the next slide the reason for that. And then processing via a Markov chain Monte Carlo algorithm, and then with Bayesian inference techniques, we provide the nowcasting and the predictions, as well as we also look at the relationships of the homicide rates with the social determinants of health variable. So for the homicide count that are reported in the NVDRS data set, we model it using negative binomial, spatiotemporal negative binomial regression framework, where it has a spatiotemporal random effects term following an intrinsic autoregressive model and some white noise model. For the flexibility, we include that. Now, our notion is like if Z denotes like the number of homicide incidents reported in the newspaper articles, it probably cannot exceed the actual number of homicides, because homicide deaths, because newspaper always underreport. And then we assume that it reports actually a binomial distribution with a reporting rate of pi. And this reporting rate actually varies on space and also on time, because if you look at the urban areas, probably their coverage is better than the rural areas. So that's why we vary this coverage rate of the newspaper articles over the space and time. And in a real scenario, if you want to predict using the newspaper articles, then you also need to predict how much is reported in the newspaper articles, because you won't be able to get that data ready. So the data are ready for the newspaper articles are like for the past year, but this year data are not ready. So if you still want to use it as a predictor variable, you need to have also predict the newspaper articles reporting data. So that's why we used a binomial autoregressive model of order 1, which gives us the ability to predict the newspaper reporting data as well. And now here, if we look at the blue lines are showing the NVDRS data set, the homicide counts of North Carolina over the years 2016 to 2022. And then the red lines are showing the newspaper articles count that we recorded from the newspapers. And on the right-hand side, you can see the correlations for these years. The correlations as expected are high in the urban areas, and in the rural areas are also like significantly like high here, like means 0.89, 0.75. It's lower than the urban areas. That gives us some promising hope that like newspaper articles could be a good predictor variable for predicting the homicide rates. And then when we look at the associations of these social determinants of health variable in terms of the incidence rate ratio, then we see the overall SVI in our model. First model, we only use the overall SVI, which is 5.85. So you can see like it's high. And then when we look at the theme specific social vulnerability index, obviously like 4 themes are, there is a possibility of multicollinearity. So what we did was we used a stepwise regression to select the variables that goes into the model. And then the ones out of the 4 themes, 2 themes that were selected are the socioeconomic and the race and minority themes. And then those are also like influential, as you can see from the screen, the incidence rate ratio as 2 and 1.93, with a 95% credible interval being 1.59 to 2.55 and 1.53 to 2.42. Now, in our third model, we actually use some variables from county health rankings and roadmap separately. And obviously, all these variables as well has multicollinearity. So same way we did some stepwise variable selection so that to avoid the multicollinearity, and these variables were actually selected in the final model. And you can see like some variables are protective, like the counties with more number population rate with some college degree are kind of less homicide rates. One variable that we noticed here is the mental health, and mental health is actually how it is measured is the percentage of population who reported like 14 or more days in a month to be mentally depressed. So this is the measure of the mental health, and you can see like the incidence rate ratio is 1.09 here. So obviously the counties with high like mental health probably could be intervened in a meaningful way. We also look at some of the model fitting like mean absolute deviance and then R squared and root mean square prediction errors. So our for model 3, as you can see, the mean absolute deviance is 1.98. So we decided to use the model 3 to proceed with the prediction. And when we predicted, then here I'm reporting the largest two counties in North Carolina, the Mecklenburg and the Wake County. So in the table, as you can see, like we provided our predictions as well as the prediction interval. So for Mecklenburg County in 2022, the actual count was 104. When our model actually predicted it to be 109 when we make use of the newspaper article data. And for 2023, we predicted it to be around 92 when the actual is 90. And our point predictions here are based on the posterior mean. And then 95% like prediction intervals we also computed to look at how precise our kind of a precision measure for our prediction. We also look at the same predictions, assuming that our newspaper article data are unavailable. Then we have to like estimate them using the binomial autoregressive model as part of our modeling framework that we used. And obviously, it is expected when you assume newspaper data are unavailable, you are adding more uncertainty to your model. So your prediction intervals the size of the intervals will increase, and that's expected. And then we also map. The purpose of this map is to show how North Carolina, like along with the prediction intervals as well as our point estimates of the posterior means. So if we look at the map, the B and E, that one with the newspaper data available and another under the assumption newspaper data are unavailable and we estimate them. You can see some clustering of the counties in the data, and then the spatial variability of the homicide rates across the states. As part of our predictive checks, we also look at the Bayesian posterior predictive checks to make sure like how good our model fitting has been done. And then like we also map like where you see the gray region means like our 95% predictive interval actually captures the value that is reported by NVDRS data. And then the white counties are those like where we missed. That means like our prediction for those counties are not captured by the 95% Bayesian posterior predictive intervals. Okay. And the overall coverage rate is around 94%. And we also saw that our like our estimates are on average like are plus or minus around 2.3 like that, which is in a sense is a reasonable like error rate, because there are, if you look at different data sources, then you will actually see different data reporting. For example, if I take the example of like Mecklenburg County, Charlotte, then the NVDRS dataset reported in 2023 the number of homicides to be 86, where the city of Charlotte reported 90. And then if you look at the CDC Wonder database, they also report 90. So like, as you can see, like there are some, like those all are like official sources, but there are like slight discrepancies in the numbers. So when our models are actually predicting in about like plus or minus 2 or 2.3, so that's within the reasonable prediction error rate. And a few things before I conclude this part of the project. I want to point out that the efforts that should be made should not be stigmatized and more equitable. And one recent NC-based study actually pointed out when they look at the EMS-based firearm injuries suggested that the racial and ethnic composition variable should be used like as an effect modifier rather than as a proxy for vulnerability. And in our analysis also, we saw that the mental health is like one of the predictive variable for the homicide rate. So there are opportunities for interventions in that area. The 2023 North Carolina Criminal Justice Snapshot corroborates the concern that there are 1.8 million adults in NC reported mental illness in 2021, and over 1 million needed but did not receive treatment for substance use, which highlighting like a kind of a treatment gap and then the opportunity for improvement. And of course, there are data challenges like spatial outliers, underreporting in rural areas, and then, as I mentioned before, the community level efforts to curb homicides were not included in the study because we don't have a database for that. And then finally, this is an ecological study, so we should not be use it for causation, but mostly looking at the association. Okay. Now, in the next 15 minutes, I'm going to talk about our work on automation of the circumstances of homicides, which is known as the manner-specific circumstance, or MSC. And this part of our work is led by Dr. Lina Zhou, and we all contributed to this work. So, like what the circumstance of homicide is, and here you see like we are looking at 8 of them. And if you asked us why 8 of them, because these are the ones that are several discussion with our liaison from the Center for Disease Control and Prevention, and those who compiled the NVDRS data set, they advised us that that we can focus on these 8 categories in the data. So, like why a homicide occurs. So one is could be like a random act of violence, and then this table actually gives you the definition of what random violence is. That victim was killed just by a random act, like there is no as such reason behind it. And then the brawl, you know, like a mutual, like physical fight that resulted in homicides. Drug involvement. So drug involvement means a drug dealing. That means a drug trade, or that when played a role in the homicide. Then argument is probably one of the leading circumstances, like argument or a conflict that led to homicide. And intimate partner violence is when a homicide or a occurred when the two people actually know each other, or they are actually the former intimate partners. Death abuse are one circumstance that occurs when in part of the neglect or by physical, medical, or emotional neglect by the caretaker. And substance abuse is when victim had a non-alcohol related substance abuse problem. And then finally, the precipitated by other crime, that means when the robbery, drug dealing, or other kind of things that lead to the homicide. Now, if you look at these 8 categories, one of the challenges, these categories are not actually mutually exclusive. So an argument can also be like an instance of homicide could be both like an argument and intimate partner violence. So then we are like taking the challenge of a classification problem where we have like 8 categories, but the categories are not mutually exclusive. And what was the motivation behind this work? Because we want to see whether like the language models or the natural language processing techniques can help processing this text data that is currently manually abstract by the NVDRS data team. And of course, from a injury and violence prevention perspective, identifying the manner-specific circumstances is important so that we can work on prevention efforts and strengthen the prevention efforts. If we know like what leads to the homicide, then we can put our efforts in preventing them. So the objectives of this part of the study is develop a classification model for homicide MSC from unstructured text data. And then we formulate the problem as a multi-level, multi-class classification. As I mentioned before, that our classes are not mutually exclusive. So for this part of the work, we look at our the data set that we use is the national NVDRS data set, not restricted to North Carolina, but we use all the data that are available from 2011 to 2021. I'd like to mention here that from 2018, all 50 states are reporting, but not all states were reporting at the 2011. But for this part of the study, we didn't use like any spatiotemporal analysis or comparing one region to the another. So that's why we kept all the data that are available from 2011 to 2021. There are total records of 100 and like almost 21,000, but then when we process the data, like we excluded where we do not have the medical coroners and the legal risk experts report. Some of those cases where like we have to remove. And also how NVDRS reports is NVDRS is an individual level data. So if like two victims are like unfortunately got killed in the same homicide incident, then for our analysis, we actually combine it to be one incident, okay? Because it's not like two separate homicide incident, but like the same one. So we combine that in like two deaths together and combine the legal expert and medical coroner's report as well. So we have 1,009 and 635 cases in form of the unstructured text data for our analysis. And then if we look at here, what actually we have in the data, you will see argument as you can expect, like it's occurred often, and then precipitated by another crime, drug involvement, substance abuse, intimate partner violence, and little bit of brawl and random violence. Those were present in the data, okay? And we actually look at those that are like more prominent in the data as part of our analysis for the manner specific circumstances. And then we also look at the co-occurrences. So it's a normalized co-occurrences, like a normalized measure from 0 to 1. And if we look at a little bit more closely, like top 8 co-occurrences of categories are like argument and intimate partner violence. So there are like 4,177 cases we saw where argument and intimate partner violence co-occurred. Then argument and precipitated by other crime, then it is 2,680 of the scenarios where we saw that. Drug involvement and precipitated by another crime, also we saw like 2,466. And like argument and again, drug involvement and substance use, we saw like 794 in the data set that actually co-occurred, these two instances together. And for the measures of accuracy, we use the F1 measures based on the precision and recall. And then also we looked at the macro F1 and also the micro F1 measures. And our data set was split into 80-10-10 for training, validation, and test sets for the fair comparisons. So we started with the various BART-based models, and then like BART, DBARTA, and then distal BART, then clinical BART, bio-BART, legal BART, all these types of models. And then if you look at the macro and the micro F1, then you see like the values like larger the values, closer to the 1 is better. But you see, like there are the values are kind of on the lower side. With Colbart is giving like 0.419, and then Distilbart like 0.501. So what we decided is we use the oversampling techniques on these models, so that those categories which are like not represented well um, in the data, and oversampling techniques actually improved the BART-based models. And distal BART, as you can see, like the micro F1 is 0.626, and then also Colbart is 0.497. So for all these BART-based models, the oversampling techniques actually improve the macro F1 and the micro F1 from the previous table that you saw. And then we also look at the large language model, the FLAN-T5 models on the original data set. So we consider FLAN-T5 small, base, and the large one, depending on the number of parameters. And for both of them, as you can see, it improved the model performances here. So 0.79, 0.83 for the macro F1. And for the micro F1, we saw like 0.67 and 0.67 for the base, and then small and base, and then 0.74 for the large models. And then when we look at actually the individual categories and how our large language models actually performed, we look at the F1 measures. Then we see, like for the argument, the F1 measures is 0.873, and argument actually represented in the training data set like about 22%. Brawl, as you can see, like F1 measure is 0.555, because Brawl is only represented in the data like 1.26% in the training data. Like data abuse, like it's like F1 measures is 0.81. And then intimate partner violence, which is like 10% of the homicide cases that reported in our databases, has an F1 measure of 0.9. Yeah. And finally, as a summary, we saw that these large language models provide some promise and can be actually employed in the real world problems, where using more complex textual data for classification techniques. The BART-based models, like because large language models, of course, require resources. As a starting point, like our oversampling techniques also provide some kind of a promising F1 measures for the BART-based models. And then it can also be tried. And depending on the resources and the size of the models, obviously, like the improvement of the classification, that varies. Now, as a final note, I'd like to say that while several challenges remain, because the data sets are like complex, and it includes a lot of information and a lot of processing of the structural and unstructural text data. But our work demonstrates that timely processing of text data are like possible, and it will improve the surveillance. And importance of unstructured data in public health and improving healthcare is paramount, which definitely underscores the need of the large language models and knowing about them. And addition of contextual variables to the NVDRS data set, which is kind of a new, and we are happy that our project actually contribute to that effort, and confirming that those contextual variables are worthy of adding to the NVDRS data sets. So now if you go to the NVDRS data website, you do not need to link the county health rankings or SVI measures, because they are already linked. And obviously, like nowcasting or like helps earlier detection of charges in homicide violence so that appropriate measures can be taken. And then also like the spatial analysis and analysis including social determinants of health enables more targeted interventions and the resource allocation for the regions where they are needed. Okay. We use newspaper articles data as a test case for our prediction models here. But from like the COVID-19 time, we saw like the importance of crowdsourcing data. There are a lot of issues with crowdsourcing data, and then obviously the methods are also developed how you are going to control the quality, the uncertainty surrounding the crowdsourcing data. But we cannot like ignore that type of data as well in the scenarios where traditional databases are either unavailable or available with a delay. For example, like archives of gun violence is a crowdsourcing technique that actually can provide you with almost like real-time data on gun violence. Okay. And then finally, I would like to conclude with the famous statement that all models are wrong, but obviously we don't know the true scenario. So obviously all models are wrong, but some models do provide like some meaningful insights to the future. And once again, thank you so much for giving the opportunity to share our work. And then if you have any questions, please let me know. And then I included some of the references here that we used for this work.
Thank you. Very interesting. I will ask members of the audience online here in the room with me. If you have any questions, please let me know. We have one person who has raised their hand. Please go ahead.
Yes, I'm Truls Osby from Duke. This was very interesting for me, and I was very impressed with the methodology and your findings here, and it's a very nice presentation. We have been working on something somewhat similar with this. The outcome is death by suicide. And what we have been using are very large databases of death certificates as our outcome. And then we have used more quantitative data from another source as predictor variables. But we are using primarily more kind of traditional epidemiological methods than what you are doing. The thing that struck me, if the point of this was not necessarily just to show what you can use newspaper articles for, but very much more practical, how can we predict homicide? Wouldn't something much simpler be to just say, I know the homicide rate in 2016, I know the one in 2017, I know the one in 2018, and then just make a kind of nice line here pointing to 2022, and you could even do this kind of by hand, nearly, the prediction. How much better is your model than a very simple model like that, just based on the homicide rate in the 5 previous years, if you use that to predict this instead of what you were doing? That was obviously a lot more elegant than what I'm suggesting.
Yeah, thank you for the question and appreciation of our work. So what we have done is we are also doing it on time and space. So like we believe like there are geographic, which actually exist, the geographic disparities, so that we can actually capture. And then one type of like the spatial models are, it's kind of assume a spatial correlations. So the nearby regions are similar, and like if we look at from the injury science also, like and that I was checking over the past few days, like can like crime has a spillover effect, like whether will the crime contained in one county, or it can have like a kind of a spillover effect, and it says like it can. And then like from that perspective, spatial models are helpful, so it borrows information from the neighboring like the counties, It also borrows information from the social determinants of health. And our purpose of adding the newspaper, although it, like, as you can see, like, it takes a quite amount of time to even process that data. And like, some people are also like using like social media data, which is like even messier, and then will require a lot more work in not only just the getting the data, but doing the bias correction. But like, because how we know, like from that perspective, like how we know about homicide first. So it's the news, that's what. And then of course, some people will say social media, because how we get the news has like eventually changed over the time. And even the newspaper, like they also have their social media like platform to share the news. So from that perspective, we thought like that can account for. And also the fact that what's going on at the very local level, like the community efforts that are being taken, we don't know that. So that's why to improve our like predictions, we include the newspaper article data.
Yeah, oh no, I appreciate that. Maybe I missed that information. But if you, instead of putting in all these extra variables, the kind of thousands of variables that presumably is underlying this, but you just use the variable that to me would be the most obvious predictor variable, namely suicide, homicide in the 5 years before.
Yeah.
How much better is this than that? Maybe you showed that, but I got a little lost in all these coefficients. But to me, that would be so much simpler. And if what you are gaining in prediction by adding all of this is very much more than what you can already do with a much simpler model with measures, then it's worthwhile. But if not, it is more a demonstration of kind of the potential of this rather than being a helpful tool for homicide prediction.
Yeah, it depends how it changes with time. Like for some places, if the kind of it's the change is kind of a flat curve or more on like a linear, then probably like taking the kind of a moving average or something can give you a better result. But if there are other factors going on and then the change is different, and then so the changes are also like not same across all the 100 counties in North Carolina. So there our model will take into account that.
Yeah, okay, thank you.
If I may, let me ask a question about where you kind of left off at the end of your presentation. What are the practical implications for officials in public health and public safety for this approach? And what might, let me ask you, if you would like to venture this far, what might be the programmatic possibilities for using these findings in developing new policies and programs?
Okay. I'd say like the immediate one that I can think of is the heavy programs or the HV programs, hospital-based like violence intervention programs, which are I cannot tell often like how many there are in North Carolina, but North Carolina has like 4 across the state, 4 trauma level 1 centers, and then so I think for them, because they also not only the bedside, they help because treating for the gun wounds is not just treating like the wounds, but there are like it's like the trauma, and then helping them getting back to the community, getting back those who are wounded by guns, whether it's suicide or it's a homicide or other type of violence. So the like HV programs can actually more look at it, which counties are more target with the mental health intervention at the community level they can do. But HV programs are also like these are it's not there is not a like a financial structure for them, like you cannot get it from the insurance companies or insurance doesn't cover it. So those programs are also like funded by small grants or philanthropy. So I think I'd say like more for them, it would be easier to see which counties or which regions they need to focus, or which variables what should be their like the way to target the interventions. Of course, not stigmatizing. Yeah.
So would this approach be something that, say, the government of the state of North Carolina would be interested in, to provide a service to each of the counties for them to be able to understand the mix of these data and the results? Because what you're describing, at least in my experience, is a fairly advanced form of art in statistical analysis, which is not a, you just flip the switch and it turns on. So do you see the possibility of this kind of approach being a programmatic service that the state would be able to offer, might be customizable at the county level?
Sure. Yes. And then if you look at the counties that are high or getting in the hot spots, then more closely looking at them, which I didn't go into the details in the talk, like looking at what socio-demographic characteristics are there, and going into deep, like what type of interventions they need, like why they are like kind of in the hotspots. And sometimes we also see over the years, like some counties are like kind of a stable, remain high. And then so that's the questions like we want to ask, like why they are consistently high and what can be done like for those counties, what are their specific needs. Okay. But what I showed you here is like the overall needs for the 100 counties, and then obviously going much deeper, like with the identifying the individual counties and looking at them, what their specific needs are.
We have a question in the room. Hold on.
And correct me if I'm misinterpreting this, but for measuring like mental health as, I think, feeling down for 40% of the last 14 days, do you think this could be applied to like an expanded version that didn't just take that categorization?
Were you able to hear that?
Yes. Can you clarify the last part of the question, like whether the mental health measure can be?
Yeah, sorry. Like, would you consider expanding for the mental health measure to be like general anxiety or schizophrenia or bipolar? Or would it just, I guess, stay within the confines of the current depression standard?
Yeah, that's a good question, because we still can like like if you look at the clinical mental health disorder, like which is clinically confirmed, then you probably will go with DSM like version 5, 20, 30, like all those questionnaires. But then we always ask like whether it's what is the actual like the measure of mental health, because that's probably too late and no point of return, or very hard to like even for clinical interventions, those definitions. So the one that we used is like we didn't create, but we just used what's available in the county health ranking roadmaps, like and that's how they are using it from the BRFS's definition, because one of the questionnaire in the BRFS is in the past 30 days, how many days you are mentally depressed, like, or whether you are 14 or more days mentally depressed. That's what the county health rankings and roadmap took that. And then like BRFS is a weighted sample. So using some weighted schemes, small area estimation technique, they provide these estimates that what percent of the population are saying like they were depressed more than 14 days in a month. So if there are like data available like on the other, as you are mentioning, like probably that can be done like using some small area estimation techniques.
Well, we are, oh, sorry, Lynn, go ahead. One more question. No? All right. All right. Well, thank you, everyone. We are out of time. And we'll thank you, Dr. Paul, for a very
Thank you.
presentation and a spirited discussion. We'll see everyone next week.
Okay. Thank you.